Hi, Assalamualaikum. I would like to present our grouping video assignment in solving integration for M80 to 38. Our questions consist of three types of methods in solving integration that me and my friends would like to present by the next slide. A. Integration by partial fraction. B. Integration by trigonometric substitution. And C. Integration by parts. Presenting my group members, Rini Farhani binti Mazlan and Adriana Alia binti Jeffrey, and me, Izahana binti Muhammad Noor.
Hi, my name is Adriana Alia binti Jeffrey, number matrix 2028-55624. And I will explaining question number 1, partial fraction. The given question, integral 25 over 1 minus x power of 2, 3 plus 2x dx. For the very first step, factorize numerator 25 and bring it to the front. Remaining partial integral denominator then expanded to become 1 over negative x plus 1, x minus 1, 2x plus 3. The expanded numerator partial fraction and then compared to formula, resulting a over x plus 1 plus b over x minus 1 plus c over 2x plus 3. This question then being multiplied to make sure the denominator is the same. After the denominator is the same, then it is easier to make it simplified into 1 equal to a x minus 1 2x plus 3 minus b x plus 1 2x plus 3 minus c x plus 1 x minus 1. From the equation we have constructed, plug in x equal to negative 1 into the equation, a then being calculated into 1 equal to 2a, a equal to 1 over 2. For the b, x equal to 1 plugged in into the equation, which b equal to negative 1 over 10 is calculated. For the c, x equal to negative 3 over 2 being substituted, which c equal to negative 4 over 5 is calculated. Calculated a, b, and c, and then being substituted into the main equation we have made earlier, which a over x plus 1 plus b over x minus 2 plus c over 2x plus 3. A being substituted by 1 over 2, b negative 1 over 10, and c negative 4 over 5. This will be simplified into 1 over 2 x plus 1 minus 1 over 10 x minus 1. This then being substituted into the main integral, which 25 times integral 1 over 2 x plus 1 minus 1 over 10 x minus 1 minus 4 over 5 2x plus 3 dx. The partial fraction then be integrated one by one, which 1 over 2x plus 1 integrate into 1 over 2 ln modulus x plus 1, and 1 over 10 x negative 1 will be 1 over 10 ln x negative 1. And for the 4 for 5, 2x plus 3 is used to let u, which u equal to 2x plus 3 u equal to 2 dx, dx equal to 1 over 2 du, integral 1 over u times 1 over 2 du, 4 over 5 times 1, this then being calculated like usual, and 2 over 5 ln 2x plus 3 is calculated. The final answer is 25 times open bracket 1 over 2 ln modulus x plus 1 minus 1 over 10 ln modulus x negative 1 minus 2 over 5 ln 2x plus 3 close bracket plus c.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sini Farhani binti Maslan. My metric number is 20211169447. Today I will explain to you about the trigo substitution. The question is to solve integrate x over square root of 2 times square root 1 minus x minus 1 square dx. So first thing first, we need to separate the constant from the equation, which will left us with 1 over square root of 2 times with integrate x over square root 1 minus x minus 1 square dx. So from the equation that we got, we can conclude where is the one a and where is the one is x. From the equation, we can look to the denominator, which is we can see which one is a and which one is x. So from the equation, the a squared is 1 and the x squared is x minus 1 square. When we already get the a squared and x squared, we can conclude from the appendix, which is a squared minus x squared is equal to sine theta. So as x is equal to a sine theta, a squared is equal to 1, so a is 1. So if we want to look for sine theta, we will get x over a. So sine theta is x over 1, or sine theta is equal to x. So we will get x as sine theta. Next is we're going to differentiate x over d theta equal to cos theta. So we will get dx over dx is equal to cos theta d theta. Next is we're going to sketch a triangle. As we know, we get is x equal to a sine theta. So sine is equal to opposite over hypotenuse. So the opposite is x, the hypotenuse is 1, and the adjacent is square root 1 minus x minus 1 square. Next, we're going to substitute our dx value with the one that we already looked, which is dx is equal to cos theta d theta. So after we substitute cos theta d theta, then we are going to substitute x with the sine x. So after we already substitute it, we can cancel out the square root with the square. Next, we can cancel out the 1, and then after that we can cancel out the sign on the above and on the denominator, which will left us with 1 over square root integrate negative cos d theta. Next, we are going to integrate the negative cos theta d theta, which will left us with 1 over square root of 2 times with sine theta, because when we integrate negative cos, we will get sine plus c. Next, we are going to replace sine theta with x. So we will get 1 over square root of 2 times with x over 1 plus c. So we can cancel out the 1, which will left us with x over square root of 2 plus c. That's all for me. Thank you.
Move to the next slide, which is integration by parts. The question is to evaluate, integrate exponent the power of 3x cos 2x dx. The solution is, firstly, we need to identify the u using the Iliad. Second, identify the dv. Third, differentiate u, integrate dv, substitute formula, and solve the problems. The u from the question is cos 2x. Differentiate du over dx, we get du negative 2 sines 2x dx. The remaining would be the dv. So the dv is integrate exponent the power of 3x. So v is equal 1 over 3 exponent 3x plus c. Next, we substitute it to the formula uv negative integrate v du. As we know, after the simplify, we need to do IBP again and repeat the steps. From the integrate e, the power of 3x multiplied to sines 2x dx, we need to do IBP again. U is sines 2x, integrate, we get du equal to 2x dx. And the dv is integrate exponent the power of 3x, and we get v equal to the 1 over 3 exponent 3x plus c. After we do IBP, integration by parts for the second time, we need to substitute it to the formula again, which is uv negative integrate v du. And after we simplify, we get the questions equal to e3x cos 2x over 3 positive 2 over 9 e3x sines 2x negative 4 over 9 integrate e the power of 3x cos 2x dx. As we can see at the figure above, the questions is same as the simplified IBP on the picture. So we can conclude that the highlighted pin there, we can substitute it with the y. So we get y equal to the e the power of 3x cos 2x divided by 3 positive 2 over 9 exponent the power of 3x sines 2x negative 4 over 9y. To be continued, we get the y equal to the exponent the power of 3x cos 2x over 3 positive 2 over 9 exponent the power of 3x sines 2x and negative 4 over 9y. And we want the y as a subject, so we move negative 4 over 9y to the left hand side and we get 13 over 9y equal to the remaining there, and we want y only as a subject, so the remaining there is divided by 13 over 9 and we get y equal to the 3 exponent the power of 3x cos 2x divided by 13 plus 2e the power of 3x sines 2x divided by 13 after we simplify it. Therefore, the answer will be substitute back the y with the question. So integrate exponent the power of 3x cos 2x dx is equal to the answer 3e 3x cos 2x over 13 plus 2e 3x sines 2x over 13 plus c.